Everybody has their own little story how they got into VR, and mine starts with a university, cognitive neuroscience. I was researching psychedelics, actually. But turns out even in the Netherlands, where you can just buy some mushrooms in a store, it's still really hard to do research in psychedelics and administer them to people. So I guess I did the next best thing that I thought of. Wait, this thing is not doing anything. Is there like a trick for this remote? Do you know why?
Because the last one, we're sorry guys, we need a checklist.
No worries, I can keep improvising. So I pivoted, right? That's what you do when things don't work out. And I decided to open an immersive VR lab within the motor control department of my university. They just had an Oculus just hidden in some box because universities, you know, some extra budget. I had to move some papers around, but I basically spent the next year researching how VR can affect movements and affect our sense of self. And I came out with that with a bunch of ideas that I want to put forward. So I founded Virtual Bytes with Matt. And together, that's basically what we do. We're an art educational little hacker thing. We're pretty new, maybe 3 months out there. And we make these little demos with videos. You can also use our scripts and develop things further. So basically what I want you to all get out of this is a little bit of an understanding of why VR is such a powerful tool for brains. And for that, I'm going to start with showing you a video. So this is an Oculus game. I hope you can all see it. It's a climbing game, so there's movement involved. They have the touch sensor so they can see their hands. And we're going to all watch suspensefully, and you can try to guess what might happen. Right. So a video really speaks very strongly here in how real this experience can be and how we as designers, as people that put people through these experiences, have to take that into account and sort of care about people's brains a little bit. So why is this so strong for brains? First, we have to understand what a brain is. So hopefully all of you have one of them, right? So give me some words about what your brain does right now at this moment. It thinks. What? Motor control. Recognizes patterns. Oh, we're getting there. That's where I want us to get to, okay? So I'm going to try to give you a very brief introduction to something that's called the predictive coding theory. And anybody who's interested in brains, read about that, okay? That's where the interesting progress is coming from right now. And this looks at the brain as a prediction machine. Your brain doesn't actually have access to anything out there in the world, nothing, right? It only knows what is coming from its senses. And based on whatever's coming from the senses, it has to try and sort of understand what's going to happen in the world. So a little bit more about why this is so important. So from an evolutionary perspective, any biological being that wants to stay alive, what does it actually mean to stay alive? It means to create a boundary between your self-organism and the environment, right? Without a boundary, you're just going to turn into a pile of mess, which I mean, at some point we all will, so it's okay. But for now, we want to try to separate ourselves from the environment. And to do that, we have to predict which states will be beneficiary for us, right? Which states will keep us away from this pile of mess. And that's why having a brain can be very, very useful. A tiny bit more. Oh, that should say past and present. What happened to my T's? I don't know. It's okay. You get it. So a little bit about how the brain actually does that. It combines two different signals, okay? One is a signal that we're all sort of used to thinking about, whatever's coming from our senses, right? We can hear, we can see, we can feel, we know where our body is, we have a vestibular system, all these things. But what also is happening there that's really important, and we're sort of discovering this in the last few years, is actually whatever the brain has already learned. Things that have happened already in the past, the brain has built a model. And these it's sometimes called priors in the cognitive neuroscience language. And your brain is constantly combining this past knowledge, these priors, with whatever is incoming into your system. It's doing this according to probability theory, which I will not scare you with. So I will scare you with this giant number, 86 billion neurons in your brain. All of them pretty smart. Okay, so when we start thinking about what's going on in here, all these neurons really have a say, but not all of them are created equal, okay? So there is a type of hierarchy in the brain that's very important. Different areas of the brain process different types of information. And as we go higher and higher in the hierarchy, the different types of information start coming together. So at the beginning, you'll just process, parts of your brain are just processing the visual signal, and the other the auditory signal, and all these different senses. And as we go higher up into the hierarchy of the brain, these signals start to come together and create more abstract levels of understanding so that we can understand that this is a chair, for instance, right? And what's important to understand is that only things that your brain didn't predict correctly go up in this brain hierarchy, okay? So if your brain gets everything right, which it never, ever, ever does, actually there will be no change and you won't even perceive anything. And there's a lot of very interesting phenomena that we're not gonna go into, but if there's absolutely no change, even your eyes constantly move a tiny bit. There's saccades that move really fast. And if you stay totally still, you'll get just a blindness will happen because there's absolutely no change happening. So now let's get back to VR, right? We learned a bunch of things about brains. Let's let that sink for a moment and try to understand what that means about VR and why it is so powerful. So VR is not only about the eyes, okay? This is, I heard someone say that, and I was like, no, that's no. Yes, your visual process is sort of the graphics card of this brain. It's very powerful, and we're going to see how powerful. But the power is combining other senses, because remember, once we combine the senses, we're going up in the brain hierarchy and activating more and more areas. So the more senses you manage to get into VR, the more powerful it will be, right? If you just have your head moving, great. The world is moving with your neck and head. That's something. That's the beginning. That's why 360 video, in my opinion, is total VR, because you have immersion there. Then if you have your hands, even better. If you get sound, 3D sound, haptic feedback, all these things that are slowly starting to get more and more into this world, you're going to get stronger, immersive, and more control over what you do to the brain. Now, because of this, you can modulate how much prediction error you're giving to the brain. And what does that mean? You can create an experience that has some very new information in it, right? You can do really basically any type of statistical correlation that you want. Some might make your users throw up, yes, but others, as we'll go through, can do really interesting things to the brain. So basically, really, if you want to get one thing out of this lecture, I want you to understand that when you're designing for VR, you should always think about what in your experience corresponds to the user's past reality. What fits in there? What's exactly sort of the same? And what is new? What are you bringing into that experience that is totally different? And there's a balance to be found there, and that's where the interesting things happen. So today we're going to also talk about how VR specifically is used for pain and in this health industry a little bit. And for that, we need to understand a little bit about pain, right? So in the past, they used to think that pain was just you have these receptors, nociceptors, and once they get to some threshold, they shoot, and you experience pain. According to what I just passed to you, do you think that's correct? No. Okay, what do we have in the brain that's really important? Priors, right? We have all these things that the brain already has learned. For instance, where am I? All this contextual information, the emotional state of the person, and what happened last time. All these things are top-down influences of how we perceive pain, and they're very, very important, and we see this in research. So, another thing that's sort of important to understand, specifically with chronic pain, sometimes you can have an injury that happened, right? But your body will heal, but your brain, the trauma still stays there. And that you can sort of think about it as a learned condition. So your brain is a type of, also a muscle, you can think about it. And at some point it learned something, and that thing got stuck. And we're gonna see how VR specifically can sometimes help the brain get unstuck. So if we said that pain, especially chronic pain, can be a learned condition, how can we unlearn it? First, without VR, then we'll see how we can apply it to VR. So a very good example is mirror therapy. Who here has heard about that? Okay, that's half. That's great. I'll give a brief summary. So it started with Ramachandran, a neuroscientist, researching amputees and phantom limb pain, right? Phantom limb pain is pain that is coming from a place that doesn't exist, right? How is that? That's according to what people thought about pain, that's impossible. According to what we know now, we understand that these predictions, there was some type of trauma, and the brain is just stuck in that trauma constantly. So what did he do? Really like a brilliant idea. This is actually what made me want to go and study neuroscience, because I could understand, wow, you can hack these brains with just these little tricks. So he put a mirror in front of amputees so they could actually see as if their leg or hand or whatever body part was missing was there. And he would have them move the body part that they do have, and they would see the body part that's missing as if it was back and healthy. And this really reduced their amount of pain. So this is an amazing hack of unlearning this pain. What is actually happening there in the brain? So one last concept we have to learn today. Can we do this? You with me? Great. So we call this, within the predictive coding theory, we call this a minimal self. A minimal self is the brain's ability to understand what is its own being versus what is not. And we take this for granted, totally, right? Oh, I know what I am and what you are. But when you think about it from a processing point of view, it's very interesting. How does the brain do that, actually? So it turns out, statistics. Once you correlate these information streams coming from different senses, the brain's best explanation is sometimes, oh, that must be one single thing because these things are happening together. And the best explanation, the best sort of demo of this is the rubber hand illusion. In this illusion, we take a rubber hand, and the person doesn't see their own hand. It's behind this boundary, as we see in the picture. And the person is getting their hand brushed at the same frequency as they see the rubber hand being brushed, right? So they see a rubber hand being brushed, they feel their own hand being brushed. What does their brain come up with as the best explanation? Anyone want to guess? Rubber hand is me, right? Rubber hand is me. They take a big hammer, they come and crush the rubber hand, you see the heart big spray, the people scream. Not necessarily a very fun experiment. But what we do learn is amazing, is how fast and how flexible this sense of bodily self, of minimal self is, right? So now let's take a look about how we can start messing with this in VR. Because we can do way cooler things than just mirrors, right? So this is a little bit about my experiments that I was doing in university. So first thing, you can put a person in a first-person view of just about anything, right? You can put them seeing themselves doing some movement that they're not able to do. That was sort of one of my theories. Can I just put a person in a body of somebody that knows their movement and tell them, okay, practice, will you be better at it? What do you think? Let's test your intuition. If you were trying to learn some movement and you were seeing yourself as if your body was doing it correctly, would you get better at it or not? Who thinks better? Okay, who thinks worse? Great, so you guys had the same intuition that I had. Wrong, okay? So, turns out that people thought they did better. They were like, yeah, this is easier now. It feels, a lot of people even thought that it was their body if they were sort of, it was correlated enough. But actually, they didn't. They really, all of them did worse at this task. Now, this is just a small research, but there was a pretty strong trend. So, what do we see here, actually? That when you get this mismatch between the visual information and the proprioception information, yeah, your brain believed you were doing better, but then, it got lazy or decided, oh, there's a mismatch, so maybe I don't listen to that one. Like, part of me is saying, you're doing great. Part of me is saying, not really. But your brain can decide, right? It can be like, I'm going to listen to this part more and sort of feedback into that. And that seems to be what happened. And this can be used for other things in a good way, for instance, like mirror box therapy. So you might be able to convince your brain it's feeling better, it's doing better, it's healing. When it comes to actually teaching movement, it might be more complicated. What else can we do? So we can do way stranger things. One of the things I did was mix the feedback senses and get them to be not the way your body is used to. So when you move your right hand, you see your left hand moving. Okay, so it's like, whoa, what is going on here? And turned out that at least under some conditions, people were actually better at mirroring an avatar. I had an avatar teach them a movement. And when I messed up with their brains, they were actually doing better. Why? Probably because I'm sort of reverting your brain to a childlike place again. The statistics don't match up. Lots of prediction error. Your brain has to start remodeling faster. Ooh, we don't understand what's going on. Let's sort of update faster. So this is another thing we can do. You really, here, the imagination is sort of the limits. People are playing with how transparent your body is, how big, how small, how long. And one of the really cool things is this research, which you can control a tail, okay, by your hip movements. And they see that people learn this so fast and are able to be more effective in this little task they invented by using their tail, just by, wiggling their hip and getting another appendage. So really, really amazing. This was just done with normal, like healthy subjects, okay? But this might have really massive application for stroke victims or for pain management too. So let's go into what is out there right now in the industry. So in universities, there's a lot of research going on, right? But what's out there as products? Not so much, but there are some things. So we're seeing a lot of what is called distraction therapy. That means you're in a very painful, you have to go some painful procedure, dentist, burn victims, and they put VR goggles on you and put you in a much better environment, right? And as we saw before, pain is also influenced by context, by where you are, by what you're expecting. So instead of seeing a hospital and big scary things, you're now, as a and as a burn victim, they're using something that's called Snow World. You're in this nice, cool world with cute little creatures while you're actually going through really painful treatments. And that shows, I think, right, you talked about this, shows really good reduction of pain. So that's one thing that's really it's out there already and can be used in many places. And we're gonna see more of this soon. Another thing that's out there is KARUNA. I do some consulting for them, and they're going through a little bit of a different path, more about what I was talking to you guys about, right? How can we manipulate the brain and remodel these things? So they're not just doing mirror therapy, they're sort of exposing the brain slowly and gradually to whatever the problem area is. So if you have, for instance, a hand injury, you'll just start seeing from a third person first, a hand moving, right? Then you can see it from a first person as if it's okay. Then you can start doing mirror therapy. Then you can start maybe getting a little bit of false feedback. So if you move your hand just a little bit, maybe you'll see it actually move more, or the opposite. So it's in a few clinics, and they're doing a lot of research in that. But that's something that I have a lot of hopes in, for this being a very new way that can help people in with many different problems. A little bit more out there, and by more out there, I mean things that are really, I guess, more creative, more on the thinking about the meditation and how we experience ourselves. One of these things is a sound self. It's an amazing experience for the Oculus, where you can sort of hum, and based on what you hum, your whole visual perception changes. There's these very beautiful shapes and colors, and you can hear your own voice feedbacking with you, and it really does something very interesting to your brain. It's creating a type of synesthetic effect, and changing this type of feeling that you have of your minimal self. Other things are things that I'm doing with Virtual Bytes. One of them is MINDMOVR that you can experience right there. You can build a whole architecture and art and then activate dance mode. And when you do that, whatever you build gets correlated to your movements. And again, after you're in that for a little bit, your brain starts correlating that and thinking, whoa, this thing is me, right? I'm controlling it. We also have Matt, my partner for Virtual Bytes, created an experience called Duet, where you can interact with a professional ballet dancer. And according to your body movements, her body will change, or her shape will change, which is really interesting too. So we went through VR for, Oh, no pictures here. Okay, they disappeared. So this was VR for pain management, but you can also do things for general health care. For instance, treat body disorders like anorexia. That's been shown to be very helpful. If you just put them in another virtual body and create this rubber body illusion, they start updating what they think about their own body. You can help heal even spinal cord injuries. This was a big research with a lot of different things that they do, but they started it out with just VR and the person seeing themselves walk again for many hours, okay? You can also treat PTSD with exposure therapy. This was also mentioned today. And I'm just gonna showcase one really amazing research that does that thing of changing your self-perception. And in this treatment, you have a therapist sitting with a person, and the person encounters a child in the virtual world, a crying child, and the therapist tells the person, you know, help that child, try to calm her, be nice. And that person, you know, says, it's okay, don't worry, you're safe, whatever comes out. And then the game switches, or the experience switches, and the person finds himself inside the body of that same child that he just calmed. And the avatar that he was, everything was actually recorded. And that avatar comes to him, and he hears his own voice and his own body movements self-calming him, right? So they really did something amazing in this experiment where they totally switched what the brain experienced. You can take you back to being a kid again and actually using the higher parts of your brain to calm yourself down. So it's pretty amazing. And this is where we're getting to the end. So if I really want you to remember this one thing, that when you're designing for virtual reality, keep thinking what in these experiences are based on the brain's previous knowledge and what is new. And if you can even test yourselves by going through these examples and think about like each of these demos and whatever game you experience, try to think about that, okay? And there's lots of opportunities there, really. And I mean, we put out two demos every month, and honestly, each of them could be turned into a full-fledged product. We're just doing like rapid prototyping, and we want to sort of educate people about the possibilities out there. And we're very happy to collaborate. And yeah, so you can come, try our things, take my card, and questions, basically.
Before we ask questions really quickly, is Katie and Chris, are you guys still here? Yeah, can you come see me over on the sideline over here? We need to talk, people. All right, I'll let you go ahead and answer.
I can't be not silly. You only need one. Is this mine? Okay. So, questions. Are the people running around with a mic still running around with a mic, or should I? Oh, yeah. Okay.
Can you just raise hands because we cannot see you? Who has a question?
No question is good. If you have any, you can.
I have a question.
Oh, there's somebody there? Okay.
So you've talked about a lot of the positive aspects of this.
Mm-hmm.
What are some of the negative aspects that you see of this?
How many of you are in marketing? Many, okay? When I see people do horror experiences in VR, that's real for your brain. Take that into consideration, right? And I pivoted to do research in VR because right now it's an open field. It's just a behavioral experiment. You need nothing. But once people start realizing how powerful this is for the brain, yes. So definitely any negative experience that you experience in there is almost as real, sometimes as real as what you would experience outside. So we definitely have to be very careful with that. And as I said before, like it could be, yeah, there's potential for evil. Yeah.
So my question is that we have this technology that can cure PTSD, but could also create PTSD to people. What types of diseases or conditions do you feel will come up in the future because of virtual reality?
So I'm very curious what will happen to children growing up without object permanence. Object permanence is when this is here, right? Right now, we don't really have that in VR. Maybe we will at some point with gloves that really offer us feedback. But right now we're sort of walking into things and we're like a bit afraid, but nothing happens. What happens to kids that grow up with this lots of times and then they actually, oh wait, this is totally different than the virtual world? That's one thing that's I'm curious about. The second is we're in so much control in this world. It's addictive. I don't know how many of you, play Tilt Brush and these amazing things. I can just be there and create my own world. Why would I want to go out there? And that's what I think social VR is going to play an important part to make sure we don't totally isolate ourselves in these worlds. But this is going to change us as humans. Yeah.
With therapy, some of the depression one that you were talking about, with exposure therapy, has there been any studies comparing sort of photorealistic or flat-out video-based versus 3D modeled, much lower accuracy, much like noticeable poly count versus just full motion video?
Not that I know of. I don't think they're doing anything with 360 video yet for exposure therapy, except they're now coming out with environmental exposure therapy. So if you have like fear of heights or of agoraphobia, they are starting to do that in 360 video. I don't think they're doing anything yet that's more than that. There's a lot of research about the uncanny valley, right? When things become real but not super real, but that's not video. Video is just real, especially, 360 video is not VR video, right? It's, we maybe some of you know the difference. 360 sphere of just one video versus really two cameras and capturing for VR. But it's a very interesting question, yeah. I think, from my perspective, my guess would be, it's when we think, again, similar versus different. So inducing a bit of difference there is probably for the best. So there's difference. First, you're in a safe environment, which is different. But having an experience that is similar but not as intense, probably better than as intense. But research is needed.
Hello.
Last question. Yes, hello.
Thank you so much for the presentation. It was super interesting and very awesome. Thank you so much. I want to ask you about, is there any books about patterns, brain pattern that might be helpful in designing in VR? Is there any something out there?
Specifically for VR, no. There's,
not for VR.
There's a lot of research papers.
Yeah.
You can contact me. I'll give you a bunch of research papers about whatever's going on in VR development. There are no designers in academia that I know. I'm sure there are designers in academia doing their thing, but I don't know of the correlation. I don't know if people are doing research from that perspective. So not that I know of. There's a few really good books. I would recommend an Andy Clark book about predictive coding to just generally understand what this thing is, how we understand patterns, how we build patterns, predictions. I don't remember its name, but if you Google Andy Clark predictive coding, you'll find it.
Thank you.
Yeah. Andy Clark, the philosopher neuro guy. I don't know what this.
Wait, hold on 1 second. Everybody, give it up for Superwoman! Put your hands up, both of them. Thank you, Sarah. That was awesome.